Okay, Helen set up an experiment as shown below. You have a wet cloth over a pot with many tiny holes by the side. There's a smaller pot inside with also many tiny holes by the side. And this is separated with wet sand and there's a thermometer inside. She placed the set up in a dry place, so it's dry outside, wet inside. Okay, so it's dry outside, wet inside. I better write that down in case I forget. Dry outside and wet inside. Alright, she's recorded the temperature of the air inside the small pot. Her results are shown below. At 0, the temperature is 30 degrees, but as the time goes to 20, from 10 to 20, it drops about 2 to 3 degrees Celsius. Now, the drop in the temperature of the air inside the small pot was mainly due to, let's see, water evaporating from the wet sand. Now, we know that water evaporates when there's warmth. So there's 30 degrees outside. That means it's quite warm. And the water here will be evaporating. So we can just imagine the water here evaporating, right? Evaporating. And what does it do when it evaporates? It takes away the heat inside and it cools and it actually lands on the wet cloth. When it lands on the wet cloth, heat is transferred to the wet cloth and the wet cloth can actually will also evaporate, right? The water from the wet cloth will also evaporate, further bringing the heat from here, okay, to outside. So you can see that as the water evaporates from the wet sand, it carries some heat because water needs heat to evaporate. And as it leaves, as it evaporates, it will touch the wet cloth. But the water in the wet cloth is also evaporating, so the heat is brought out from the inside of the container to outside, to the outside air, to the outside dry air. All right. Okay, so what actually has happened? You can see that water evaporates from the wet sand. That is correct. Looks okay, but let's check the rest first. Heat being conducted to the thermometer. I mean, the heat needs to touch the thermometer for the thermometer to work, but that does not explain the drop in the temperature. We are explaining the drop in the temperature. Okay, so that would mean that 2 is not so correct. Okay, and then 3, water vapor condensing on the wet cloth. Now, like I said, water vapor will condense on the wet cloth. Alright, but that again does not explain, because if the heat from here goes to here, the amount of the overall heat inside would remain the same. But heat needs to escape from the wet cloth out. So this does not explain the drop in the temperature. Let's look at number 4. Wet sand acting as a poor conductor of heat. So you have the wet sand acting as a poor conductor of heat. Yeah, okay, so the wet sand does act as a conductor, as a poor conductor of heat, but again, that does not explain the drop in the temperature of the air inside, because to start with, the air inside is the same temperature as the air outside. Alright, now if the air inside acts as the temperature as the air outside, so let's say this is 30 degrees and this is 30 degrees, right? This acting as a poor conductor would mean that this would remain 30 degrees. Instead, this has dropped to 27 degrees. Okay, so the reason why it has stopped is because heat is managed to escape. Okay, so wet sand acting as a poor conductor of heat does not explain the drop in the temperature of the air inside. Okay, so the answer is quite obvious. Okay, I'll repeat my video once again if you don't understand how to derive the answer. If you already understood, then just remember what has happened in this diagram so that during the test you will be able to answer it well. Thank you.